Okay, welcome back. I I'll run through what I did. So I opened a folder in the desktop and named as spy, and I opened another folder called target, and I went open the target and I highlighted this, copied here, went to file on the IDE. I changed the workspace, go to switch workspace, click on other, and make sure you are working on the same the spy target, and then click on launch. Will bring you this screen. So we don't need the information center. I'll close this, and then you need to start a new project. File, new, STM32 project. STM32 project. So this will allow, and it will take some time to select the board because we are doing scratch from the workspace, so sometimes it takes a while to do that. So we got to patiently wait until the system allows us to do, because the blue circle is still going on. So just bear with me. Oh, there it is. So first we need to include the two data parts from CMSys and the core M4, then the symbol. Initially it has to check a lot of things, so that's why it takes a long time. So there it is, board selector. We're going to use Nucleo F411, so please type that and get the board and select it. Select that board and then next, and the project name is Day26 Spy Part 1, and then choose empty for the targeted project type and then click finish. We're going to use the internal built-in header files. So for that you need to do those 3 steps if you remember. I'll go to source, open the main C, and I'll remove all the default lines, and I will build the project. So that will give us I'll zoom in a bit. Window editor, zoom in so I can see better. Window, yeah, and then I'll delete all the pre-written programs. As you know, this is for the reference, I'll leave it as it is there. Now I'll just go and simply build so that the ELF file will start to generate first, and also it will check for any errors. As you can see, there is a 19% build. So it takes a while, and the .elf file is generated, which is the one we want. 0 errors, 0 warnings. In order to use the built-in header file, you need to do 3 things. So go back to the target, the spy folder, and go to this STM cube extraction. You have to first go to drivers, the first step, drivers, then go to CMSys, and then go to device, go to STM32F, and include this. Make sure the STM32F411xe.h header file is in here. So copy this path, copy, come here to the project name, right click on the project name, go to properties. In the properties, select C++ build. In C++ build, go to settings. In the settings, go to MCU GCC compiler. In the MCU GCC compiler, click on include paths. And in the include paths, click on the add icon, that's a directory. So paste the link and then click OK. So the first step is connected. So the next one, you need to also copy the device path core M4. To do that, just go to device. It will be inside drivers, CMSys, under core, and then include. You need this core CM4 header file. So copy this path and also do the same. So go to the project name, do a right click and go to properties. Okay, I'll apply this. I'll show you step by step. Yes, apply and close. Okay, so again, now you go to project name, right click, properties, C++ build, settings, MCU GCC compiler, include paths, add the second path. Yeah. Okay, so the two paths are included. Then apply yes to it, and then apply and close. So now you link the paths, and now you can include this line to include the built-in header file. I'll show you, there will be an error. So being a built-in header file, it has to be written in quotes, double quotes, stm32f4xx.h. So I'll just go and save. You will get an error because we haven't declared the project. We haven't declared the symbol. So you'll get these three errors. Just nothing but it's showing that the Cortex M4, these are all connected, but it's missing a device symbol. So to do that, just simply select this, right click, open declaration, and then go and find that lab, the symbol STM32F411RE, this one. So we need this. XC, copy this, come here, right click on the project name, go to properties, go to C++ build, go to settings, go to MCU GCC compiler. This time click on the preprocessor and watch here, it is not on the list, define symbols list. Click on add, define symbols, you just paste that symbol STM32F411XE. It's copied and paste it, apply and say yes, and then apply and close. And you don't need this file, so now you just go here, right click and build the project. Now all the necessary paths and the symbol is declared, so you won't get any error. The next step, we'll go and start to write the code. Okay, 0, 0, that's really good. Okay, the first step is we're going to write the GPIO code. So for that, first you got to define the function SPI underscore GPIO init, initialization today of void. So you declared that. So copy, and we're going to write the function. Okay. So this time I will go to the data sheet. I will also show, that's the ADXL345, which I will show you later. This is the alternate function. We're going to use pi1, so we're going to use PA5 for serial SPI serial clock. PA6 is used for SPI1 MESA. PA7 is used for SPI1 MOSI, and we're going to use the GPIO for the chip select, so we're going to use PA9. And if you check on the alternate function, it's AF05, but I'll show you the register that we need to work on. So we need to enable the clock access for first the GPIO register. So first GPIO RCC. First you need to enable the clocks. So I'll go to the RCC register. First you need to enable AHB1 ENR. So we're going to use GPIO A, that is the port A, so you need to enable the port 0 as 1. And also I2C1 is connected to peripheral bus 2, so you need to enable APB2 ENR as well. APB2 ENR. APB2 ENR, we are going to use Pi 1 enable, so you need to enable the bit 12. So these two are the first steps. First, clock access to GPIO A and SPI1. To do that, you need to do RCC AHB1 ENR register, and you simply R that with GPIO A enable. So this is the one. Before doing that, you need to declare the macros. So macros hash define GPIO A enable GPIO A enable is nothing but the first pin, so 1 U of bit 0 and the 12th bit for SPI 1. So hash define define SPI 1 enable, and this will be the 12th bit. U okay, so that's not I, it's 1 U. Okay, so next step, I'll just simply copy this. It's a clock access for GPIO A. This is clock access to SPI 1. So this is APB2 ENR. APB2 ENR, and this is, we have to copy SPI 1 enable. Okay, then this next step is you need to set the those pins for all those 4 pins. So you need to set the model register for all those pins. So next step, set output model register for PA5, PA6 and PA7. So we're going to use the GPIO A. So again, go back to the data sheet. Data sheet. No, sorry, the reference manual, and go to output data mode register. So go to GPIO model, GPIO model register, which is this one. So we're going to use PA5, which is that's PA0, 1, 2, 3, 4, 5. We're going to use this as the alternate function mode. So to do that, you need to set 1, 0. You need to write 1, 0 in all those bits. So 0, 1, 2, 3, 4, 5. So you need to write bit 11 as 1 and bit 10 as 0, and this is PA6, 13 as 1 and 12 as 0, and PA7 we're going to also use. Bit 15 will be 1, bit 14 will be 0. So that's what we're going to write now. So GPIOA model register PA5. We are going to use the PA5. So bit 10 to write 0, you need to AND that with a negate and then declare that pin. So this is PA5 bit 10. I'll copy this and also use it for the bit 11 has to be 1. Bit 11 has to be 1. To write as 1, you just need to simply R. That means it's 1, PA bit as 1. So likewise, you got to do for port A6 and port A7. Port A5, this is port A5, port A5. Copy this again. You're going to do for 3 times. This is 6, this is 7. This will be 12 and this will be 13 and this will be 14 and this will be 15th bit and this will be PA7 bit 15 bit 14. This is bit 13 PA6, this is PA6 and this will be bit 12. So after this we need to set the chip select output. So for that, set PA9 as chip select and as output. So as you know, as output, so again go back to the registers. If you want to use the output model as just as an output, then you got to write as 0, 1. So this is PA 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you need to write bit 19 as 1, bit 18 as 0. That's what we're going to do. 0, 1. So bit 19, 0, bit 18 as 1. So I'll just copy these 2 lines. We need that lines. Come here and paste it. This is PA9 bit 18 bit 18. This will be bit 19 PA9 So this will be 18 and this will be 19. So I'll just Control X, Control V. I'm just organizing, sorry. Okay, so the chip select, slave select is done. So the next step after this is to define the alternate function register. So you need to set all this to SPY1. SPY1 we are using PA5, 6, 7 and PA9. So the corresponding alternate function from the table is AF05. So that's what we're going to do. Set AFR with SPY1 registers as 5, 6, 7, which will be on the AFR low registers, and the value will be AFR 05. That is, you need to write 0101 on all these alternate function registers. So to do that, I will start writing 1, then I'll show you GPIOA AFR of 0, and you need to set the bit as 1 U 20. And I will copy this, Control C, Control V, and this will be AFR register, Control C, Control V, AFR register, and this will be 21. Okay, you need these two again for bit 22 and 23. Bit, it will be 22, 23. So we are writing bit 20 as 1, bit 21 as 0, bit 22 as 1, bit 23 as 0. So that's what we have written. If we go here, this is the port mode register. If you keep going to alternate function register, pull up data register, alternate function low register, you need to go. Alternate function low register, because we're going to use, this is 0, 1, 2, 3, 4, 5. So the bits 23, 22, 21, 20, you need to set it for AF5, because from the alternate function table that's linked to AF05. We go to the data sheet, alternate function 05 is linked to SPI1, PA5. We're going to use clock, meso and mosi. It's all linked to AF05, so that's why we are doing. So to write AF05, you need to use, that's 5, 6 and 7. So you need to write 0101 on this 4 bits, and again this 0101 on these 4 bits. So AF5 value is 0101. That's what I have written here. I'll simply go and copy this and I'll paste it twice. Copy. 23, so this will be 24, 25, 26 and 27, and this will be 28. As you know, it's a 32-bit. 29, so will be 30, and this will be 31. Okay. So now we need to set we set the output data, so we don't need the GPIO 31. Okay, this is all the config we need. Yeah, so after config you also need, after init you also need a config register. You need to set all those configurations, so copy another one. This time it will be SPI config, SPI config function. Copy. Okay, in the config, then int main. I will just quickly check for any errors at this stage, so we can check as we go along. So right click, build the project. It's building to 23%. Okay, 0 errors, 0 warnings, which is always good sign. So now let's go and define all the configuration bits. The first step will be, you need to use the status registers and the control registers one. So go here, reference manual, you need to go to SPI CR1. So I'll click on the contents, scroll to SPI, that's a GPIO, ADC, RTC, I2C, SPI, and then SPI registers, you need to go to SPI control register. So you need to set all this configuration. Clock phase, you need to set clock polarity, bit to master, and the bit rate. We're going to use 4001, that is the frequency of the peripheral clock divided by 4. We're going to set this into the speed, so we will be setting bits 5 to 3 as this value 001. So bit 5 will be 0, bit 4 will be 0, bit 3 as 1 to use that. And then the other bits called DFF, SSM, SSI, the LSB first bit, all this will be configured one by one now. So we're going to configure the control register. So first set the FP clock 4. To do that, you need to do SPI 1 control register 1, and just simply R that with 3 times. Because we're going to set the F clock by 4, that means the bit rate, baud rate generator 543, so 001. So that's what I'm writing. I have just written bit 3 as 1, so now I need to go and write bit 4 and 5 as 0 for the clock generation. So I'll simply copy this and modify this. this will be bit 4, and to write as 0 you need to negate, and you need to simply AND that. That's 4, and we also need a 5th baud rate. So 3, 4, 5. Okay, so then you need to set the clock polarity as 1 and the clock phase as 1. Next step, set cpol equals 1 and cpha equals 1. So that means bit 0 and 1. If you go back to the register, you need to set these two, 1 and 0. 0 and 1. So we need to set, I'll just copy this, twice, and then I will change this to 0 and 1. Okay, then the next step is configure the SPI in full duplex mode. Configure in full duplex communication. So to do that, you need to set the bit 10th bit as 0. So if we go here, the 10th bit, RX only. If you go bit 15, 14, 13, 12, 11, and if you go to 10, if you want to use as full duplex, that is both transmit and receive, you need to set this 10th bit as 0. So that's what we're going to do next step. 10th bit as 0. So we need to copy this, Control-C, Control-V, and then change this to bit 10. Then you need to set the master bit, which is bit number 2, master. Because this is SPI, you're going to control one master to slave, so you need to set bit 2 as 1. Set bit 2 as 1. For that, you just copy this, come here and paste it and change this to 2. Okay. After you set that as a master, then make sure you need to transmit MSB, transmit, come on, transmit MSB bit, most significant bit, and set this. Because in the register it has got only LSB first, so bit 7, if you come to bit 7, to make this as MSB transmitted first, you need to make this bit 7 as 0. So that's what we're going to do. Bit 7 as 0, so again you copy the SPI 1 to transmit MSB first, then change this to bit 7, MSB first. And after you transmit MSB first, then you need to configure data as 8-bit mode. So you got to use the data frame format, and that's on bit 11. Go back to the register, bit 11, if you see data format, if you want to use this, you need to set this as 0 bit DFF. here bit 11, you need to set that as 0. So again copy this and change this to 11. 7 and then 11. After the 8-bit mode chosen, then you need to select the software, select software slave management bit. So to do that, you need the internal slave select and also the slave select management. So that's bits 8 and 9 you need to set, these two bits 8 and 9. So go back, you need to set, so we need just the R, copy this, and this will be 8th bit and this will be 9th bit, it's the same. So after selecting that, then the final step is the SPI enable, SPI one enable. So to do that, SPI one enable is a 6th bit, as if you remember, if you come to 6th bit, SPE bit 6, you need to just SPI enable. If you set as 0, then that means it's disabled. If you set this bit as 1, that means its peripheral is enabled. So that's the step. Control C, Control V, and this is bit 6. So we have configured all the necessary pins that we need. That's well and good. So save and do a right click and check for any errors at this stage. 0 errors, 0 warnings, that's really good. So now the next step, you got to write the chip select enable. So you need to also use the chip select for it to enable and disable, and that's very simple. So after config, I will create 2 more functions for chip select enable and disable. Copy this, paste it, chip select, one will be chip select enable and the other will be chip select disable. And then write a function for enable first. So copy this, come down, so in order to enable the chip select, you need to enable the output data register. That's if you go to ODR register, output data register, this is alternate function. Okay, it's better go by the contents, so we need to go to GPIO registers. GPIO registers, you need to go to output data register, that's a port output data register, ODR. That's the output data register. You need to, because we're using PA9, so that's the bit 9, so you need to use this bit. So I need to just set this bit because that's a GPIO bit. That's why it's easy. So GPIO-A and set the output data enable is, you got to negate that. Negate 1 U, sorry, 1 U 9. Okay, and next function is the disable function. Disable is the opposite, so I need to just set void cs disable. You got to just set this bit. Yeah, so we have written the program for now. I will go and save and do a check. Okay, 0 errors and 0 warnings, which is a good sign. With this, the initialization part coding is done, and we also did SPY configuration, also CS enable and CS disable. The rest we will see in the second part. So far we covered all of this and it's all working okay. So with this I conclude this session. I will go back here and finish off for the day. So what we learned today so far, you learned about the SPY and all the basic fundamentals of the SPY, and also you learned about how the timing diagram works, and also you went and learned about how the SPY work. So as I keep saying, you got to also build your mindset as well when you develop your skill set. And I would like to bring this to you today by the famous Willie Nelson once said, get rid of the negative thoughts as soon as you get that in the mind, immediately discard that. Otherwise that will lead to only thinking about negative terms. Instead, change the negative thoughts with the positive ones and you will have positive results. So always be positive and everything will be positive. No matter what happened in the past, don't dwell on the past. Past will make you to learn the lesson, so take that whatever the past lesson has taught you and replace that to the present and the future, so you know what to do and where to go, what to hit to achieve your goals. So please change all your negative thoughts to positive thoughts and all the positive things will start to happen. And please don't forget about the involvement, the top 10 goals, and write your top 10 ideas to achieve your goals. And please at least spend 30 minutes to do some exercise, and please spend 15 minutes to do some meditation just to free off your mind, and 10 minutes to actually visualize that you achieved those goals, and another 10 minutes to plan for the rest of the day activities, and 2 hours you get 2 points for learning and capturing the notes. Please do post all your achievements in the Facebook group. This will help each other as we are helping each other out, and this will motivate us, and we'll be able to learn everything as a group. And there is combo internship coming up. I don't want to put everything in one single course, so I divided it into 3 different courses. To get the full experience of Cortex M4, please do purchase the beginner, intermediate and the advanced course. And also please stay tuned with us. These courses are in progress and you will be the first person to know, and when it is ready you can enroll to them and update your skills accordingly. I take this opportunity to thank each and every one of you to be with me to learn another communication protocol on part 1. Please go and enjoy that deserving break from the screen. This is Arul and Bukarasu. I am signing off on behalf of A2DG. Huru for now. I'll catch you in the next session. Until then, take care. Catch you later.